Hey everyone, Mrs. Spatola here. These are the answers from last night's homework. So what I would suggest is pause the video and take a look. And here are the rest of the answers. Today we're going to be looking at the greatest common factor in word problems. So turn the page and here we go. Unit 4, Lesson 6, Greatest Common Factor Application. How can the GCF be used in real-world situations? Before we move on, what is the greatest common factor and what is it used for? So when we think about the greatest common factor is the largest factor that two composite numbers or prime numbers have in common. So the GCF is the largest factor that two or more numbers have in common, and it is used to simplify fractions, or as we're going to see today, in real-world situations where certain things have to be calculated. Please make sure you get that down and that you understand what the definition means. Let's take a look at number 1. A baker has 24 sesame bagels and 30 plain bagels to put into boxes. Each box must have the same number of each type of bagel. A. What is the greatest number of boxes that the baker can make using all of the bagels? All right, so this particular, and letter B says how many sesame bagels and how many plain bagels will be in each box. So the first thing, as we know when we're solving word problems, is that we have to make sure we understand the question. So let's look at it one more time. A baker has 24 sesame bagels and 30 plain bagels to put into boxes. Each box, so every single box, has to have the same number of each type of bagel. So what they're asking here is, it should, when I look at a box, it should have the same number of sesame bagels and plain bagels in each box. So we have to figure out what the greatest number of boxes that the baker can make using all of the bagels. So basically what they're asking you to do here, it doesn't come right out and ask, but you have to imply or infer. They're asking you, what is the greatest common factor of 24 and 30? And then for letter B, what they want you to do is determine how many sesame bagels and how many plain bagels will be in each box. So let's go ahead and do the work. We're going to make a T-chart. So let's start off, and you might have to move to the side a little bit. We're going to make a T-chart for 24 and for 30. So go ahead and do that. Pause the video, and then once you do your T-chart, come back. So when I make my T-chart and I list all of the factors, then to find the greatest common factor, what I need to do is I need to find the common factors. So 1's in both, 2's in both, 3 is in both, 4, no, 5, no, 6, yes, 8, 10, and I look through the rest and none of the rest are in common. So the greatest common factor of 24 and 30 is 6. So you can see that the greatest common factor of 24 and 30 is 6. So the answer to the question, the greatest number of boxes that the baker can make using all the bagel is 6 boxes. Now let's take a look at the second part of the question. How many sesame bagels and how many plain bagels will be in each box? So what you could do is literally draw a picture if you like. Okay, so we know there's going to be 6 boxes, 2, 3, 4. Don't you love my artwork? 5 and 6. We're going to pretend these are all the same size because Mrs. Spatola is an awesome artist. Okay, and now what we have to do is determine how many sesame and how many plain bagels. Well, here's an easy way to figure it out. If you go to your T-chart, we know that 24 represents the sesame and 30 represents the plain. So if we know that the GCF is 6, check this out. If I circle this, if the greatest common factor, I know there's 6 boxes, there are going to be 4 of the sesame in each box. So there's 4 sesame in each box. This is just a visual. You don't even have to draw the picture, but if you'd like, I know me, I like to see pictures and I know that I need to see it in order to understand it. And then for the plain bagels, if we circle that, now notice, if we use the T-chart, it's just the number that's on the opposite side of the greatest common factor. And then in each box, there will be 5 plain. 5 plain. So there's 5 plain. And if you do the math, you will see that the 4s, if you count out 1, 2, 3, 4, 5, 6, 4 sesame in each box will make it so that there are 24 total sesame, and 5 times 6 for the plain bagels, you'll see that there are 30 total plain bagels. And there you have it. So that's our little bagel box question for the morning. Okay, of course, it's always about the food. Let's take a look at number 2. For number 2, it says the 6th graders are competing in a field day. There are 32 girls and 40 boys who want to participate. Each team must have the same number of girls and the same number of boys. A, what is the greatest number of teams that can be formed? And B, how many boys and girls will be on each team? Well, this is set up pretty much the same way. We are focusing on greatest common factor application. We're not throwing in any trick questions here. So if we follow the format, we're going to do the same type of procedure. So the first thing is going to be to do what? So if we look back at the first problem, what did we do? We have to find the greatest common factor then of 32 and 40. So let's do 32 and 40. And pause the video, find the greatest common factor of 32 and 40. Okay, using the T-charts, I'm going to go through the T-charts, and I notice, instead of making the list for this one, if you like to make the list, go for it. It's awesome. But we can use the chart. So if I go through here, I see that 1 is in both, 2 is in both, 4 is in both. 8 is in both. And that's it. So I can see that the GCF, or the greatest common factor, is 8. So now to answer the letter A, what is the greatest number of teams that can be formed? The answer would be 8 teams. But now they're asking us how many boys and girls will be on each team. Well, if I look here, I know that 32 represents the girls and 40 represents the boys. So now all I have to do basically is take a look at my T-chart, and I look at the number opposite the 8 on each side. So if I look here, I notice that 8 times 4, and then for the boys, 8 times 5. So the number that's opposite the greatest common factor in the T-chart is basically going to be the answer to your question. So for boys, I can see that opposite the 8 is the 5. So there will be, for boys, there will be 5 on each team. And for the girls, there would be what? Good, 4 on each team. So 5 boys and 4 girls on each team, and we're done. Let's save number 3 for another day, and let's go on to the next page and look at number 4, because you're going to be completing for homework numbers 5 and 6 on your own. I will tell you that number 4 you will definitely see at our end of unit assessment. So it says, Patty has 18 pencils, 27 erasers, and 36 stickers. What is the maximum amount, greatest amount, of equal pencil cases she can make using all of the items? And then if you look here, they're asking you the total number of pencil cases, and then how many of pencils are in each bag. So pencils in each bag, erasers in each bag, and stickers in each bag. So this is a type of problem that pretty much you see once, and if you follow the format, we are working with the greatest common factor. So the first thing we're going to do is reread the question. Patty has 18 pencils, 27 erasers, 36 stickers. What is the maximum amount? So what's the highest amount? Maximum, they're asking you the greatest amount. And when you see the word greatest, that's your clue. What I would even do is say, okay, they're asking us to find the GCF, the greatest common factor of equal pencil cases she can make using all of the items. So think about it. We have pencils, erasers, and stickers. So we have the numbers 18, 27, and 36. What do you think we're going to have to find now with 3 numbers? Right, you're going to have to find the greatest common factor of 18, 27, and 36. Pause the video and do that now. If I go through the list of each of them now, I have my T-charts for 18, 27, and 36. If I go through each one and I just glance across, I can actually see what the greatest common factor is. Can you see it? Well, if I look in 18, the first thing I want to do is compare the charts. So I see that 1 is in all of them. I see that 2 is not, so I know that 2 is not the GCF. 3, I see 3 is. Now let's go through. How about number 6? Is 6 in all of them? Nope. How about 9? Aha, 9. Ah, look at that. 9's in all of them. 18, nope, it's in 2 of them, but not all of them. So based on that information, your greatest common factor is 9. So now let's go and see what the information they're asking us. So the total number of pencil cases is your greatest common factor. That's going to be 9. So now all you're going to do is look in your T-chart, look at the number that's across from the 9 in each category, and that will tell you the number of each item inside the bag. So let's go over to number 18. So across from the 9, I see there is a 2. So that would tell me that there are 2 pencils in each bag. For the erasers, here's the 9. I see that the 3 is across from that. So there are 3 erasers in each bag. And for 36, I look over here, I find my 9, and I can tell that there are 4 stickers in each bag. And guess what? You're done. So let's look at number 5 and number 6. Number 5 and number 6 are very similar type problems. You're going to find the GCF of each item and then answer the questions as they appear. Now, next class time, we do have a quiz coming up. So let's just talk about what would be some concepts that you should know for the quiz. You need to know the definitions of a prime number, composite number, divisor, greatest common factor. You need to know the definition of a factor and a product. You need to know how to find the greatest common factor of 2 numbers using a T-chart. You need to be able to use prime factorization, a factor tree, for a number. And then you're going to have a couple of numbers. You're going to have to answer whether they are prime or composite. And then lastly, you're going to be looking at 2 fractions to tell if they're equivalent. That we did in yesterday's video, but if you need to, all you need to do is check the cross products to see if they are equivalent or equal. And there you have it. This is Mrs. Spatola wishing you a great day, and remember, always be kind.